All right, we're looking at the 5.3 and 5.4 guided notes. Here, we're going to introduce two equations, two forms of a line, the slope-intercept form and the point-slope form. And I cannot express just how important it is to pay attention to the names of things. So let's just make sure we're on the same page as far as our vocabulary is concerned. When it comes to slope, slope is m equals, it is the ratio of rise over run. And really, again, this is just the change in y over our change in x. Nothing more than the change in the rise, change in the run. Now, a point, that is simply an xy ordered pair. And we've plotted many points. So a point is just an xy ordered pair. The y-intercept is a very specific point. That's whenever x equals 0. And graphically, this is the y-intercept. It's where the line crosses the y-axis. Very important to note that the y-intercept is where the line crosses the y-axis. Alright, so let's see if we can put this into motion here. So the slope-intercept form of a line. This is the one you've been doing forever. This is the one you know. This is y equals mx plus b. I wish I had that big echo voice. That'd be awesome. But it's just nothing more than y equals mx plus b. M, again, is our slope. And b is our y-intercept. So the slope-intercept form of a line. Not too terribly difficult there. And in general, I just want to see what this looks like here. Yeah. These will be numbers. The y and the x are just simply y and x. The m and b are the numbers. So, this makes each line unique. The m and the b are what makes each line unique. So let's try and see if we can graph a line using slope-intercept form. So the way I suggest to use it, it's really a two-step process. First of all, we want to apply it to y-intercept, and then we want to count the slope. So our b value here, b, is 4. And our m value is negative 2 over 1. Make sure you do the over 1 part. That's very crucial to making sure we get the correct slope. So if it's just a whole number, remember it's divisible by 1. So we're going to start by plotting our y-intercept. So we count to 4. So we go 1, 2, 3, 4. And here's my y-intercept. And then I'm going to count my slope. And again, rise with the sign and then run to the right. So here I'm going to go down 2 units and to the right 1 unit. So I'm going to go down 1, 2 units and to the right 1 unit. And here's my second point. There's an old mathematician. His name's Euler. No, not even Euler. Let's go further back than that. His name's Euclid. He, back in ancient Greece, he wrote the first book of mathematics, and he said it takes 2 points to draw a straight line. And here are my 2 points, and there's my straight line. Alright, so let's go take a look. That coffee is good, I tell you. Let's take a look at the next guy here. If you've already done this, if you already tried it out and gave it a shot, great. I I want to make sure you're using a straight edge when we draw our lines. Lines in this instance, they are perfectly straight. So there's plenty of rulers in class, and if you need a straight edge, grab a ruler from my desk and make sure you use it. I want to see nice, neat, straight lines here. There's no sense in messing that part up. All right, so my b value this time, b, in this instance, b is -1. So my b is -1. And my slope, m is 2/3. So I'm going to get 2. I'm going to rise 2 and run 3. All right, so I'm going to start with my b value at -1. I go b down to -1. Here we are. That's my y-intercept. This is where the line crosses the y-axis, is at -1. And now my slope is rise 2, run 3. And my sign is positive. It's not negative, it's positive this time. So I'm going to go up 2 units and run to the right. 1, 2, 3 units here. And now I have the second point. Oh man, let's see if we can get this. This one's going to be tough to draw. So I'm just going to have to do it in 2 parts. Alright. And it goes forever that way, and forever that way. Oh, make sure this guy goes forever that way, and forever that way. Okay, so now we can see just how easy it can be to draw a graph of a straight line in slope-intercept form. Again, starting with our y-intercept and simply counting our slope. Now, there's the other thing I wanted to teach you guys is the point-slope form of a line. The point-slope form of a line, if you have a point and you know your slope, then you can put this together. So the point that you get is x1 comma y1, and our slope is m. So the point slope form of a line is y minus y1 equals m times x minus x1. So let's see how that plays out here. And really, let's see if I could do this. If I could do this. If I can do this. I'm going to do this here. Let's say my M is blue. And I'm going to say, alright, so the y and the x, it's just x and y. That is your normal x and y. Those are simply x and y. And the m and the y1 and x, or the x1 and the y1, the m, those are numbers that you are given. So here we see our x1 and our y1. And here is our slope, m. So let's piece this thing together then. So I get y minus, and my y1 value is 3. So I'm going to say y minus 3 equals m. My slope here is -2. So -2 times x minus, now you want to use parentheses whenever you get these negatives just to make sure, minus -4. Well, x minus -4 is really saying x plus 4. So I'm just going to rewrite this to make this look a little bit nicer for me. I get y minus 3 equals -2 times x plus 4. Now, again, we have to distribute this entire -2. It's got to go to the x and to the 4. So I get y minus 3 equals -2 times x is simply -2x, and -2 times 4, that's -8. And now I want to solve for y, so I add 3 to both sides. I add 3 here and add 3 here, and I get y equals -2x plus, oops, excuse me, it's still negative. there, minus 5. That doesn't look great here. Just because I want to make it look a little bit neater. A little bit neater. Y equals negative 2x plus 5. There we go. All right. So we're going to have a worksheet for this in class on block day.